Well, hopefully at this point I haven't scared everybody off and everybody's trying to drop the class because it's too late. You can't drop the class at this point. You got to stick it out and hang out to the end now. So again, it's a little bit trickier just because of how complicated the degrees of freedom formula is and stuff like that. But otherwise, it's still very similar. So this one, like proportions, goes back and is a little bit easier because again, with this one, we're going to be using like the z-score type stuff. And so the z-score stuff tends to be easier. The alpha level is going to stay consistent just like it has been for all the z-scores. So this one should be hopefully a little bit easier to handle than maybe the last section. So first thing to notice, so again, we've got same four steps as we had before, but in this case, we do want to actually pool the proportion. So when we're doing t-scores, we don't want to pool the data, but when we're doing proportions, we do actually want to pool the data. And so what we'll have to do is we'll have to calculate this probability of pooled, which you see is going to come up down here. So that's kind of the equivalent of like our old p hat in this case, or our kind of like our population proportion in this case, in a way. So we'll have to calculate that at some point in time. So our hypotheses, so again, these are going to be exactly the same, but instead of mu's, we're going to have p's in all their different spots. So our test statistics, so again, notice this is a z-score, so this goes back to what we like. And again, we won't know the population proportion, so we won't have that P1 and P2, so it's really just going to be P1 hat minus P2 hat divided by that pooled thing that we're going to calculate from above, and then multiplied by 1 over n plus 1 over n2, and then the square root of all that stuff. And then again, calculating our p-value is going to be exactly the same as we did before, so we have to use the z-score version of it. We can't use the like any kind of percentage version or anything like that. And then our conclusion, again, same thing we've been doing. So only little changes here and there, otherwise it's mostly the same. So in our calculator, so again, we can use two prop z test instead of one prop z test, since it's a two variable instead of a one variable. And again, that would just give us the full answer right away. So in this section, I would recommend you just using the two prop z as a way to check yourself, because again, I don't think these will be quite as hard as maybe the section 2 that we did. All right, so let's dive in, looking at an example here real quick. So the National Health and Nutrition Examination Survey weighed a sample of 546 boys aged 6 to 11 and found that 87 of them were overweight. So they weighed a sample of 508 girls aged 6 to 11 and found that 74 of them were overweight. Can you conclude that the proportion of boys who are overweight differs from the proportion of girls that are overweight? So again, in this case, that differs tells us that we're going to use the equals, not equals situation. But before we go down that road, let me write down some stats here. So I'll just go ahead and do boys as the first one. So in this case, our probability of boys were the 87 that were overweight. Our N1 is the 546 total that were actually surveyed. And in this case, our P1 hat is just going to be 87 over 546, which if we type in the calculator, it's going to be like 0.16, it looks like. So in this case. All right, so now let's do the same thing for the girls. So P2 was 74 girls. Our N2 was 508 girls that were surveyed. And so again, if we look at our P2 hat, we're going to get 74 over 508. So in this case, we get 0.15 or 0.145. So I'm just going to round it to 0.15. So probably shouldn't be rounding it this much, but we'll see how it works out. And so in this case, so we need to do our hypotheses. So again, since this is a differs, it's going to be an equals, not equals. So P1 equals P2. P1 not equals to P2 in this case. So that's good for step 1. So now for step 2, we want to calculate our test statistic. So this is where we're going to have to calculate the probability of pooled. So in this case, let me just write down the formula real quick for everything. So our Z is going to be, so P1 hat minus P2 hat, all divided by the square root of P pooled, I think what, times 1 minus P pooled. And then times 1 over n plus 1, or n1 plus 1 over n2 in this case. All right, and then just to remember, P pooled is going to be x1 plus x2 all over n1 plus n2. Because again, with pooled, remember, we're kind of combining the data together. So that's what we're doing with this calculation. So before we can do anything with the z-score, we need to do the p pooled first. So in this case, we're going to get our... Oh, I wrote this down wrong. Sorry, let's see. Hold on, let me go back here. I wrote this as P1. It should be X1 and X2. Sorry about that. Hopefully somebody would have caught that if we were in class. So in this case, we've got 87 plus 74 all over 546 plus 508. So again, putting these in the calculator, 87 plus 74 is 161. 546 plus 508 is 1054. And then calculating 161 divided by 1054. Looks like we're going to get 1.153 in this case. So I was going to leave it as 0.15. We'll see how bad this could be with rounding. So, all right. So now it's time to plug everything into our z-score now that we've got our p pooled. So in this case, we've got z equals p1, which is 0.16, minus p2, which is 0.15, divided by the square root of 0.15 times 1 minus 0.15 times 1 over 546 plus 1 over 508 in this case. Alrighty. So now to the calculator. Let's see. So we've got, oops, get out of there. So we've got 0.16 minus 0.15 gives us 0.01 on the top. And then on the bottom, we're going to get square root of, so parentheses 0.15 times 1 minus 0.15. And then big parentheses here, 1 plus, what was it, 546 and 508. 1 plus, or 1 divided by, 1 divided by 546 plus 1 divided by 508. So make sure you got the parentheses just like I've got them there. And make sure, if your calculator doesn't happen to, notice my square root's kind of coming along with me. If you're not sure whether yours is doing that or not, it doesn't hurt to put, an extra set of parentheses around this whole entire thing. So that way it makes sure that everything stays inside the square root, because we don't want it to come outside the square root. All right, so that gives us that for the bottom number. So now if we do like we did last time, 0.01 divided by second answer. It looks like we get 0.45 as our z-score in this case. So let's write our z-score down. Oh, 0.45. Let me write it over here so it's easier to see. All right, and so again, since this is a regular z-score problem, once we know our alpha, we can immediately find like where the fail to reject and the reject, not or reject H naught range is. So in this case, since alpha wasn't given, that means our alpha is 0.05, which means that if I divide this guy into half, in this case, so that would give me, what would it be? So 0.025 here and 0.025 there. So from there I can use inverse norm, because again we're doing plain old inverse norm stuff, and calculate that lower z-score by doing just 0.025. So if I do second vars inverse norm 0.025 comma 0 comma 1, then that should give me negative 1.96, which is what I got, which is perfect. And since this is symmetric, I get it at the upper level for free, because remember this is a two-tailed test, so we want to make sure that we actually do both tails, so we want to do that with it. And so now what we want to do is kind of just as an initial, so remember if you're in the blue, we're in the reject H naught. If we're not in the blue, this is the fail to reject. So our z-score is 0.45, which is going to fall somewhere in here. So since it's pretty clearly in the white, it looks like this is going to be a fail to reject H naught one. But again, there's a possibility that we made a mistake in our calculation, so we should go ahead and do the normal CDF as a way to do this one. So in this case, since our z-score is positive, then that means I want to do the upper bound. So I'm going to make the 0.45 the lower bound for my normal CDF. So normal CDF, 0.45 comma 100,000 comma 0 comma 1, and then type this in the calculator and we'll see what our p-value is. .45 comma 100,000 comma 0 comma 1. So we get 0.32, but now remember this is a two-tailed test, so we need to actually multiply this answer by 2. So if we multiply this by 2, we're getting a p-value of like 65%, which isn't good at all. So I want to do 2 times this, which is giving me 0.65. So in this case, 0.65 is clearly greater than 0.05. So that supports our fail to reject. So that means we've got it 2 different ways. So that means we must have done this right. So now we can draw our conclusion. So in this case, since our p-value is bigger than alpha, we fail to reject so there isn't sufficient evidence to support the claim that there's a difference between obesity and boys and girls in this case. There isn't sufficient evidence to support the claim that they're and girls in this case. All right, so now let's do it real quick using the calculator just to kind of like show everything here. So let me see what I need. 86 and 546. Let's go to the calculator. So again, go to stat, test. So in this case, we want 2 prop z test. And so we had, oh, I totally forgot it again. So 87 and 546. And 74 and 508. And so again, we've got our z-score, which looks similar. So our z-score is going to be off by a little bit just because I rounded a lot. So I think that's going to mess these calculations up a little bit because you can see they've kept all the p-values and stuff like that. So we're all right up to rounding, but so my z is going to be a little bit off from what we had because of the rounding. But again, that's not too bad. So again, we want to make sure we're on the equals, not equals. And so we can see we got a p-value of 0.53, which again is a little bit different than what we had because of rounding. So what do we have for our p-value? 0.65. So again, I rounded stuff probably a little bit more than I should have, where the using that way won't round it that much at all, which is kind of nice. So otherwise, this looks really, really good. So there's a bunch of practice problems on for you guys. So I've left it so you could find your own alpha levels just because that is easier to find. So, but if you get stuck or have any questions or anything about any of these, please let me know. I'll be around the computer all day tomorrow. So good luck and have fun.